It is late in the evening. The sun has already gone down, and this is the second time opening it, or the first time opening it after the second test run. And so we're going to see how much the plates have, the inside housing piece has shifted. So this is the housing, and let me just show you. So the rotor has more discs, and they're also spaced closer together. Now tomorrow I'm going to have to paint this whole thing. I need to paint all the internals to kind of reduce the amount of corrosion potential going on. And you can see I have 12 bolts going through now, and they're all, like I said, these recessed heads, but the end plates, these thicker plates, were still so thin that I didn't want to make the recesses any bigger because of the chance that it might pull all the way through the disc and then the disc is ruined. So, when I tighten it. So we're just gonna, keep it as it is for now. It seems to be running fine. And, tomorrow I will take this whole thing apart and I'll show you the whole construction of this disc stack. Because it's really simple. It's a super simple design. And there's basically thinner plates, and then the outside edge is thicker plates. And so the part that was rubbing would have been right there. That's the part you heard at the end where it was making a lot of noise, a lot of racket. And this whole housing is made of cast iron, and I need to paint it, prime it, and then paint it, of course. You can see the paint has completely disintegrated. And that's expected. This paint is not, this is literally marking paint for like surveying. And I just had some sitting around. And so what this piece does is this keeps the steam away from that outer wall, and it makes just a smoother surface for it to run along. And the way it is that you have the nozzle, and then this metal plate just is to guide the steam off of that nozzle and make it go around without hitting any obstacles. And so it's literally just a plate, just a piece of, it's actually metal siding from a house. Some type of either siding or flashing. And all it is this little springy disc thing. And it's just meant to overlap on one end. And what I want to do is I want to drill 2 holes in it, and actually rivet them together. And then one other thing is it has this tiny little, you can't really see it, but it has this tiny little bend. I don't think I can get it to focus. I'll have to film in better light. Yeah, I can't get it to focus, but this edge, okay, there we go, you can kind of see. This edge has been bent towards the outside, this tiny little bend. And what that does is that this housing, because it has these splines in it that catches, that little ledge essentially catches on these splines. And so, yeah, you know what, I'll end it here. I just wanted to show basically the part that was rubbing, and it went through the paint, obviously, and but it doesn't look like it actually had too much of a problem. It just kind of shifted a bit. So what we need to do is the same design, same idea, but just slightly thinner metal. When I paint the housing is going to be smaller diameter because of the thickness of the paint. So either I use the thinnest metal I have, or I sand down the disc, which I don't want to do, but that is an option. Or I could use a Dremel and sand all these little splines, which would take a very long time. It'd take forever to do that. So I think we're just going to go with trying to get thinner metal, and yeah, and then just finish it properly. So I'm going to let this thing dry out for the rest of the night. And then tomorrow we're going to paint this, and when I take apart this whole stack of discs, I'm going to show you the construction. And I think you may have seen it before, but I'm not sure. I don't know. I don't think I actually showed the inside, but it's a super simple design. It just has these 12 bolts going around, and every one of those has washers between each of the discs. And the washers are super critical. Not only do they keep the disc from flexing and changing shape, which would cause all kinds of problems. Also, that would affect the efficiency, but they provide more torque, more starting torque for the thing, because basically it makes an eddy current when steam is coming in. Steam hits these little bolts and the washers around them, and it makes eddies behind it, and the eddies transfer a lot more of the energy to the disc. So that's something I learned after I had built the thing, but when I was only had 6 of these, and I was contemplating doubling it up. I watched the video of the guy, like the foremost expert on Tesla turbines, talking about it at a seminar in the 90s, and he talked about the very critical importance of these bolts. And so that's all it is. It's a bunch of discs, some washers, an axle, and a housing. And really good bearings. I have the best bearings that I have, or at least the smoothest running bearings that I have, and even they are not the best. And I just made out of stuff I had on hand, you know. So we will be back, and we will show you the whole thing. Oh, and also we're going to make CAD models. Try to make a CAD model and find common materials that everyone has, household materials, hardware store materials, and figure out how to make it easier to build these things. This took me a while to build, only because I had to go through multiple iterations of the design phase before I got it working. But, you know, it's really simple. I built the whole thing with a drill press, a Dremel, and some hand tools. That's it. No lathe, no CNC machine, no high precision instruments, literally just hand tools. And ideally you would build this properly with a machine shop, and you'd have everything very precise, very, very well balanced, and it would just run a lot smoother. It could run at higher RPMs. You would have more efficiency because the gaps between the housing and the rotor would be smaller. The rotors, you know, would be the exact most optimal thickness, and everything would, you know, be just better. But I mean, for something that's built by hand, I think that ran pretty well. Just with that tiny little boiler, which is undersized for the turbine, we got up to, I'd say, at least 4,000, 4,500 RPM, maybe 5,000. One day we are going to put a Hall effect sensor on it, and we're going to figure out what speed it's actually running at. So that will be a future project. I need to learn about microcontrollers. Oh, feed water. I have a bigger one that I want to keep, but this one is going to be sacrificed and turned into the feed water pump. It's a 300 PSI electric pressure washer. Someone threw it away, and that is going to be how we get water into that boiler and any future boiler. So this is coming apart tomorrow. And, I mean, yeah, I guess I could make a video about that. Once it's disassembled, I'll show kind of the inner workings of the thing. I think it's a swash plate pump. It's basically a bunch of cylinders that are all parallel, and there's a plate that rotates, and it has like a ball bearing thing. It's multiple plates, and they basically make the pistons go in and out. It's called a swash plate. And they also make engines using that, a swash plate engine, but I've seen inside of larger pressure washer pumps before, and I've had to repair a couple. One time when I was in a line of business that required a pressure washer, and so that's how they make them. And they're just designed for very high pressure. They're designed for water, and so, you know, they're not going to corrode. So that's perfect for our purposes. And so I will see you in the next one.